Hello everyone, this is Katish here. This is question number 9 from the AQA 2018 Physics Paper 1 higher tier for the separate science. This question is on the energy topic. Question number 9. Figure 15 shows a coffee machine. The coffee machine uses an electric element to heat water. The coffee machine has a metal case. Why would it be dangerous for the live wire of the electric cable to touch the metal case? Now, if the live wire touches the metal case, then you're going to experience an electric shock. So, there's a risk of electric shock if someone touched the metal case. Or you could say, you can get electrocuted or risk of electrocution. Question 9.2. The power output of the coffee machine is 2.53 kilowatts. Now, when you're using these values in calculation, you need to make sure they are not in kilowatts. The power has to be in watts. So let's change that. To change 2.53 kilowatt to watt, you would multiply that by 1000. Remember, kilo means 10 to the power 3. So that makes it 2530 watts. The mains potential difference, in other words, the voltage is 230 volts. Calculate the current in the coffee machine. So you need the equation that links current, which the symbol is I, potential difference is V, and the power is P. So the equation that links all three of them is P equals IV, or power equals the current multiplied by the potential difference. So substituting those values, 2530 equals the current multiplied by the potential difference, which is 230. Rearranging the equation, I equals, or the current equals, 2530 divided by 230. So 2530 divided by 230, that gives me 11 amps. 11 amps. Next part. Question 9.3. The coffee machine heats water from 20 degrees to 90 degrees. So here we can do the calculation for temperature change. So from 20 to 90, the temperature difference is going to be 70 degrees Celsius. So the temperature is increased by 70 degrees Celsius. The power output of the coffee machine is 2.53 kilowatts. So change that to watts, 2530 watts. The specific heat capacity, remember the symbol for specific heat capacity is C, power is P, and this is delta theta. What we found, 70 degrees is the temperature change. Calculate the mass M of water that the coffee machine can heat in 14 seconds, which is the time. Now for 5 marks, this question involves the use of two equations. So using the power value and the time, I can find the energy. I would need the energy in order to find the mass using the specific heat capacity equation. So the first equation, power equals energy transferred divided by the time, or energy transferred is power multiplied by the time. The power is 2530 multiplied by 14. So 2530 multiplied by 14 gives me 35,420 equals 35,420 joules. Now I can use this value in this equation. Remember, energy transferred equals the mass multiplied by the specific heat capacity multiplied by delta theta. So I can rearrange that equation to find out what mass is. Rearranging that means mass equals energy divided by the specific heat capacity multiplied by the temperature change. So 35,420 divided by specific heat capacity of water is 4,200. They have given that value here. Multiplied that by 70. So 35,420 divided by, actually let's try it the other way around. Delete. Yeah, open brackets. 4,200 multiplied that by 70, close brackets. As it I've used the calculator to input the numbers exactly the way I've written it down. So if I put a bracket here, right, that should give me an answer of, and that to decimal 0.1204. So I can round it off to 2 decimal place. 0.12 kilograms. 0.12 kilograms. That's about 120 grams, and the answer is correct. That's the end of question number 9. I'll see you in the next question.